Name of subject, internal combustion engines. Name of chapter, introduction. Name of the topic, deviation of actual Otto cycle from theoretical or ideal cycle for 4-stroke SI engines. Contents, deviation of actual Otto cycle from theoretical or ideal cycle for 4-stroke SI engines. Dear friends, in the last few lectures we already started to see everything about the engines. We started with the definition of engine, then we discussed about the engine construction and its detail, its terminology, etc. We also discussed about the classification of internal combustion engine. Then we had the Otto cycle and its derivation, as well as the diesel cycle and its derivation part itself. So, when we talk about the Otto cycle, which is a theoretical cycle for all petrol engines or all SI engines, okay, so today we are going to understand the deviation of actual Otto cycle from theoretical or ideal cycle for a 4-stroke SI engine. Okay, so Otto cycle, whatever Otto cycle which we discussed in the last lecture, that is a theoretical cycle, and that cycle was invented by Nicholas Otto. Okay, and that is one kind of a theoretical basis for all the petrol engine. But when we are going to apply this particular cycle practically to the engine, to the SI engines, we will not, or we will never get the cycle like this one. Okay, so here on your screen we have the two diagrams. One is a PV diagram of theoretical Otto cycle and another one is a PV diagram of actual engine cycle. Okay, though we are applying this particular Otto cycle to the engine, to the SI engines, we will never get practically such kind of a curves. Okay, so we know these particular Otto cycles, different curves. 0 to 1 is a suction, 1 to 2 is a compression, 2 to 3 is a heat addition, this 3 to 4 is a expansion, 4 to 1 is a heat rejection, and 1 to 0 is again exhaust. This is the theoretical way or theoretical Otto cycle itself. But when we are going to apply this particular Otto cycle to the actual engine, and when we are going to measure or when we are going to get the cycle of operation, we will not get the curve like only this. We will never get the curve like this of Otto cycle. Okay, whereas when we are going to apply the Otto cycle to the actual SI engine, the curve will come like this one only. Okay, if you observe this particular diagram, this particular pressure and volume curve, totally different curves we are getting when we compared with this theoretical cycle. Okay, please observe this Otto cycle and please observe the actual cycle itself. Again, here 0 to 1 we got the straight line, but here 0 to 1 we never get the straight line. There will be something curvatures. 1 to 2, 2 to 3, 3 to 4, again 4 to 5 and the 1 to 0. Every cycle of operation, every curve is different in actual cycle. Why this is happening in the actual engine? Why this is happen in the actual engine? There are the different reasons, and that comes under the deviation of actual Otto cycle from the theoretical or ideal cycle for 4-stroke SI engines. We are going to understand the different reasons. Because of that reasons, we never get the actual cycle like the theoretical ideal cycle or theoretical Otto cycle. Okay, so we are going to understand the different reasons. Because of that, we are not getting the curves similar to the theoretical Otto cycle. This is the theoretical Otto cycle and this is the actual or real engine cycle. Okay, so here there is a need to understand with the help of the notes part. So we are moving to understand with the help of notes. Okay, so again here we have the deviation of actual cycle from air standard cycle. Okay, so again the same kind of a diagram here I have drawn like this. Okay, this 0 to 1, 1 to 2, 2 to 3, 3 to 4, and again 1 to 0. This is the real engine cycle or actual cycle, and which will differ from the theoretical cycle. Again, this is the clearance volume, this is the swept volume, here is the volume, here is the pressure, this is the ignition point, and this is the total volume cylinder, which we already discussed. 0 to 1 is a suction, 1 to 2 is a compression, 2 to 3 is the heat addition process, 3 to 4 is the expansion, and 4 to 0 is the exhaust process. Okay, which we explained already. Okay, so here we are going to understand why we will get the curves of actual engine of operation like this, which is totally different from the theoretical Otto cycle for the SI engine. Okay, now here we are going to understand the different reasons. Okay, the actual cycle of IC engines differ from the air standard cycle. See, the theoretical cycle is also called the air standard cycle. Okay, so don't get any kind of a confusion. Whenever the question will come in your examination, explain the difference between the air standard cycle and the actual cycle. So air standard cycle means what? The theoretical Otto cycle. In many aspects, the differences are mainly due to, now one by one we are going to understand what is the first difference or what is the first reason. Okay, what is this? The working substance being a mixture of air and fuel, vapor, or finely atomized liquid fuel in air combined with the products of combustion is left from the previous cycle. Yes, dear friends, we are using air and fuel mixture in the case of SI engine. Okay, but theoretically Mr. Nicholas Otto never thought about, or he never suggested whatever amount of product of combustion which is remains inside the engine cylinder because of earlier stroke. Okay, definitely there is some kind of a product of combustion which remains inside the engine cylinder because of earlier stroke, and every time fresh air and fuel mixture will mixes with the product of combustion which is left from the previous cycle, and definitely this affects on the actual cycle itself. So this is one of the reason, or this is one of the difference. Okay, because of that there should be a deviation between the actual cycle and that particular theoretical cycle. The second one, the change in chemical composition of the working substance. Okay, always the chemical composition of the fuel like petrol as well as air, there should be some changes. Okay, no one will tell there is a 100% correct chemical composition is present over there. As the petrol properties will be somewhat changes, then there should be something changes in the chemical composition. Okay, as the quality of air will be changed, definitely there will be changes in the chemical composition. So whatever change will happen in the chemical composition of working substance, there should be, or there will be some changes may happen in the cycle. Then the third one, the variation of specific heats with temperature. Yes, definitely there should be some variation, specific heat. As the environment will change, the specific heats will be again change itself. So this is one of the reasons. The fourth one, the change in the composition, temperature, and the actual amount of fresh charge because of residual gases. So as I told you earlier, some kind of product of combustion which already remain in the engine cylinder. Okay, as the air fuel mixture will burn and during expansion process that will convert into gases, and that some amount of gases may remain inside the combustion chamber of the engine, and that gases will acts along or reacts along the fresh air fuel mixture composition. That becomes the, in the form of temperature changes, the amount of fresh charge will be changed like this, and this will again affects. Okay, the fifth one, that is the progressive combustion rather than the instantaneous combustion. Okay, so in this case what happens, sometime the combustion will happen progressively as compared with the instantaneous combustion. So this is again definitely this is one of the things, because of that there should be some difference. So the next one, the heat transfer to and from the working medium. This is the another reason. Okay, Mr. Nicholas Otto never thought about the heat transfer from the engine to the different components. If you observe, the silencer is always hot. Is it right? Similarly, the different component near to the engine, there is a lot of heat is present over there. When you are going to touch to that particular component, there is a huge amount of heat is there. Okay, hot particles are there. So what is this? This is the heat transfer from the engine to the different components, and this affects the cycle itself. Similarly, the seventh one, the substantial exhaust blowdown loss, that is the loss of work on the expansion stroke due to early opening of the exhaust wall. Okay, so Mr. Otto considered inlet valve will open, exhaust valve will close according to the cycle of operation, but sometime it will not happen. Later on we will talk about the valve timing diagram also. Sometime this will not happen, and again because of this one, sometime there should be a loss of work on the expansion stroke. This is the one of the reason. Again, the next one, the gas leakage problem, fluid friction in actual engine. This is almost some such kind of losses are present in the real engine itself. And Mr. Nicholas Otto never considered this kind of losses. So these all are the reasons. And now out of all above factors, which tend to decrease the thermal efficiency as well as the power output of the actual engine. Okay, so along with this, the time loss factor due to the time required for mixing of air and fuel, and the second one, the heat loss factor, that is loss of heat from the gaseous cylinder wall, and the third one, the exhaust blow down loss factor. These are the different reasons. Because of these all reasons, the ideal Otto cycle never same as compared with the actual cycle. There should be always some deviation. So all about this, the deviation, I think I hope you understood all these things thoroughly. So we stop our today's session. Thank you so much for watching this particular lecture. Thanks a lot. Here we stop.